Second.
All right, Jennifer. Jennifer, you're saying something.
I was like, I'll join.
Okay, so I'm waiting for most of your colleagues to join before I continue. That's why.
Okay.
All right. Okay, so we have 40 minutes remaining, then that'll be the end of today's meeting. So the thing is, I'm saying within a myelinated axon, action potential takes place at the nodes of Ranvier. And also, when the neuron has myelin sheath surrounding it, it means that action potential is very fast than a neuron that doesn't have any myelin sheath surrounding the axon. Okay. So one thing you should also note.
Okay. Please come again.
Okay, so I'm repeating. I'm saying that within a myelinated axon, so right now you know that the difference between a myelinated axon and unmyelinated axon. I've already explained. So I'm saying within a myelinated axon, in most situations, action potential takes place at the nodes of Ranvier. But when the neuron is what? Is unmyelinated, we normally say that action potential takes place within the axon. Also, within a myelinated axon, action potential is very fast than an unmyelinated axon. So these are the things, the key things you're supposed to know.
Thank you.
Then, as I said, action potential takes place here. This is a typical action potential. Then another action potential will take place here. Another action potential. So every section which contains nodes of Ranvier, action potential will take place. So it means when information starts from the dendrite, then it moves to the cell body, then it moves to the axon hillock, and it gets to a myelin sheath. Information is very fast until when it gets to the nodes of Ranvier, then an action potential will take place, leading to a jump. Then another information will take place at another action potential, another nodes of Ranvier, and so on. That's what happens. So if, let's say, within one axon, or within, yes, one axon, we have 5 nodes of Ranvier, it means 5 action potential will take place within what? These nodes of Ranvier. So please, any questions so far? That's what I want you to know, the thing I want you to know. If you have any clarification, please, there's a time. So information jumping from, or action potential moving from one node of Ranvier to the other is sometimes referred to as saltatory conduction. Saltatory conduction. That's what the system is all about. So per my explanation, I want someone to explain what saltatory conduction is all about. Okay, Richie.
Yeah, so to my understanding, it is the rate at which information jumps from one node of Ranvier to the other.
Exactly.
In the axon.
Exactly. In a myelinated axon, you need to indicate that, not an axon.
Okay.
Exactly. So it happens when what? Action potential moves from one node of Ranvier to the other within a myelinated axon. Simple. All right. So please, any question? Oh, nice. So then let's move on. So I want to stop sharing, then I'll go back to your slides. Your slides were ready. Okay. I want to see if I've covered everything. Today we wouldn't discuss action potential, or else it will be it's a whole lot, and I don't want to bombard you with a lot of information, or else it will be a lot for you. So in our next meeting, we would delve deeper into what? Into resting potential and action potential, so that you grasp the concept well. All right. So please, any questions so far? So it means in our next meeting, we'll be talking about what a resting potential is, action potential, refractory period. These are the key things we'll be talking about. We wouldn't talk about synaptic transmission. That one is also a lot. Okay, Jemfua, your hand is up.
Yeah, so I think if I get it right, the solitary condition is when action potential move from one node of Ranvier in a myelinated axon, right?
Exactly. That's the function of, that's what saltative conduction is all about. And these are the key concepts you are supposed to know, because in exams, Dr. Anu can just ask you, so what is saltatory conduction? Or it can be in your objectives. When or action potential moves from one node of Ranvier to the other in a myelinated axon, this process is known as saltatory conduction. All right. So if there are no questions or whatsoever, then I think, okay, is someone's hand up? Tracy. Tracy, your hand is up.
Yes, sir.
Okay.
Please, my question will be taking us back a bit.
Okay, no problem.
Hydrocephalus. You said it's caused when the ventricles, the CSF would contain too much fluid, and that causes the hydrocephalus. And I'm asking that, what causes the blockage of the ventricles?
Good. So sometimes, especially during birth, in birth, it sometimes happens genetically. Some people, the moment they are born, you can see that there are somewhat blockages happening within their brain, their ventricles. Okay, sometimes too, it could be more or less like maybe infections when a kid was very young, or even when the baby was in the fetus. There are certain things maybe the mother did, especially maybe the mother was exposed to lead poisoning and so on and so forth. It could cause the baby to what? To have some of these things. And when there's a blockage, then it means that the CSF wouldn't flow like it has to flow. Then in that regard, the baby's head will swell up, causing the hydrocephalus. And please, I need to do indicate this. When hydrocephalus happen like that, it means that surgeons or doctors, they are supposed to, they do something to what? To drain the cerebrospinal fluid so that the baby head or what will come into a normal state. And they use a normal procedure. Who knows what the procedure is all about? Yo. Who knows what the procedure is all about? Should I give it to you as an assignment? Okay, so they normally use a procedure known as shunting. Who did it? So please, who knows what the procedure is all about? Hey, a lot of people, they have raised their hand. Let me cross-check. Okay, Ralph. You raise your hand first. Ralph.
I had a question, sir.
Okay, so before your question, anyone knows what the type of procedure is all about, how they do it and all that? Okay, so one thing, if you know, you can just unmute yourself and speak. Okay, so in most situations, they have a tube, okay, that they use to drain the CSF out. So they will connect that tube to the baby's tummy so that the CSF will be drained to the baby's tummy. Then with time, the baby's head will come to a normal state. So it is a simple medical procedure that they do just to reduce the swell up of CSF within the brain. All right, so Ralph, your question.
I know there's not a right, but during the Sakai lesson,
Okay.
yes, I had a question, but I think the examiner was out of the page.
Okay.
So we're talking about the sympathetic nervous system.
Mm-hmm.
And we asked, the question was, at what time can the spinal cord act alone? So she gave an example where when you bring a sharp object near a person's eyes,
Yeah.
there is that withdrawal. Now, my question is, did this happen with the help of the sympathetic nervous system?
Exactly. One thing is, you remember I said the sympathetic nervous system, it is found within where? The peripherals, right?
Yes.
Good. So in most situations, the sympathetic is just there to cause fight flight. So this is not a typical fight flight.
Okay.
But with this, it is more or less like we call it a reflex act or a reflex action, which is taking place. A reflex action mostly takes place within what? Within your spinal cord.
Sure.
And thank you for even drawing my attention. I think I skipped something when I was talking about the neurons. The neurons, we can have different types of neurons.
Mm-hmm.
Okay, we can have the sensory neuron. Let me write them here. Sensory neuron, then motor neuron, and interneuron. So please, anyone can talk about any of them they know, the sensory, motor, and interneuron? So what's the function of the sensory neuron?
Its function is to interact with the environment, receive input from the environment, and transmit it.
Good. So first, sensory means sense. So it means it receives information from what? From our sense organs. And you know the sense organs receive information from the environment. So that's why he said it receives information from the environment. Then those information is sent to which part? The central nervous system, consisting of the brain and the spinal cord. So in books, sometimes they will say the sensory neuron receives information from our sense organs and send it to the brain and the spinal cord, also known as the central nervous system. And sometimes the sensory neuron is sometimes called afferent. It's very, very key for you to know, because sometimes your lecturer wouldn't bring sensory because he knows that sensory neuron is common. All of you know what sensory neuron is. Sometimes he will indicate what is the function of the afferent neuron. It is the same as he's saying what's the function of the sensory neuron. Okay. Then the motor neuron. Please, what's the function? Chris, your hand is up. Is it for this question or you have different set of questions for me?
Yes, I have a different set of questions. So when you are done, I will ask my question.
Okay, Richard, you too. Is it for this question or you also have another question for me?
It's for the hydrocephalus.
Okay, so we come to that. So let me clarify this now. So one thing is with the motor neuron, we normally say that it receives information from the central nervous system, consisting of what? The brain and the spinal cord, and then send it to the muscles. Then the last one is the interneuron. The interneuron connects information from the sensory neuron and the motor neuron. Or sometimes the interneuron, we call it relay neuron. It means the same thing. Then motor neuron is sometimes called efferent neuron. So these are the things you need to know, the terms you need to know. Then interneuron is also known as relay neuron. All right. So please, if there's no question, then when it comes to these types of neurons, then Chris, you can go ahead and ask your question.
Okay, my question is, what I wanted to say is that some of us, because most of the students could not pay their school fees, they couldn't join the Sakai platform, or they were not registered on the Sakai platform.
Okay.
And the link wasn't circulated earlier so that most of us can join. And if there's a recording or there's a way of making up to we those who join late, it will help us a lot, because the class is really, we are enjoying the class.
Okay, so as we are speaking currently, I'm recording everything. So one thing is Zoom normally, when we are done, it records, then it will automatically convert it into what? Into a small size. So most of the recordings that I've done, it has been what? Recorded and converted. So when I'm done with the lecture, I'll circulate it. I'll forward it to your course rep. That's Esther. Esther is your course rep, right? I think she's the one who forwarded the link to you because I sent it to her personally. So I'll forward it to Esther. Then Esther will share it on your page so that you have access.
Okay, thank you very much.
You're welcome. Okay. So Richard, your question.
Okay, so mine is not a question, it's an input.
Okay.
On this hydrocephalus, we have two kinds. It's congenital and acquired. And the treatment has two forms. It takes either shunt surgery or neuroendoscopy.
Yeah.
And in the process, what actually happens is a thin tube for the shunt is implanted in the brain.
Yeah.
That helps to drain the spinal fluid very slowly
Exactly.
into part of the body, like the tummy, which later help it to circulate into the blood system.
Nice.
So this is a process it takes.
All right. Thanks so much, Richie. So any other question or input or clarification on what we've done so far? All right, Angela.
Okay, you talked about fluid, too much fluid in the brain. Is there any situation where there is less fluid in one's brain, and then how does it look like, or how is it? Thank you.
If there's less cerebrospinal fluid, then it means that the person is having what difficulty, or there's malfunction in terms of the ependymal cells. You know, I said the ependymal cells is a glial cell, and its function is to what? Is to produce the CSF. So if the person has what? Less CSF within the brain, then it means there's that sort of what malfunction or damage or lesion within the ependymal cell leading to that. That's what happens. Okay, Listowell.
Sir.
Yeah.
Sir, please, I want to know the function of the fluid in the brain.
The function of
the fluid.
Oh yes, I indicated. I said I gave about 3 of them. Please, who remembers what I said with the function of the cerebrospinal fluid? I want to find out whether you recall what I was saying.
Hello, sir.
All right, yeah.
I remember that you said, for instance, those who do boxing and those stuffs.
Exactly.
In case you hit your head against each other, the fluid will protect your brain from damage.
Exactly. So the fluid what cushions the brain or protects the brain from shocks. Okay, then there's another person's hand. Is that Musa? iPhone, Musa.
That was what I wanted to say, but look like the lady has already clarified.
Okay, Musa. Portia, your hand is out.
Yeah, it produces nutrients or nourishes the
exactly.
brain.
It nourishes the brain. Okay, Richard, your hand is up.
It acts as a reservoir to regulate the contents of the cranium.
Okay, so you're saying it acts as what? As a reservoir to do what?
A reservoir. To regulate the contents of the cranium.
Okay. Then one thing you should also know is that it even was to some extent removes some waste materials from the brain. All right. So these are some of the functions you are supposed to know. Richard, your hand is still up, or is it for the previous one? All right. Ophelia, your hand is up.
Okay, so I have a question concerning the shunting.
Okay.
You see, there were blockages in the ventricles. That's why the CFS couldn't flow.
Yes.
So as the shunting is being done, are the blockages being removed so the CSF can flow, or is there something else being done?
For the blockages to be removed, then it means that they are supposed to do a serious surgery. And one thing about the brain is that when they open the skull and do that, it could cause a lot of damages, because you doing that, you can damage some of the cell tissues and all that. So the shunting serves as a temporary thing, so that when there's a lot of CSF within the brain, the tube would then pass some of the CSF onto the person's stomach.
So it's not a one-time thing.
It is a temporary thing that is done. It is not.
But you don't do it once.
Removing the blockages. It doesn't remove the blockages.
Okay.
It just drains out the CSF, so that it wouldn't accumulate more, leading to the swell up of the head.
Okay, so you have to do it frequently and not just once.
The thing is, the tube, they just do it once. Then anytime there's a large accumulation of the CSF, it just pass. Some of the CSF moves into the tube and goes into the stomach.
Okay.
I hope you get it.
Okay. Yeah, I get it. Thank you.
Okay, Richard.
So I'm talking in terms of over drainage.
Come again.
When I see over drainage, when you allow the tube to over drain too quickly from the brain. Yeah, sometimes I think the implications or the complications can also be seizures or vomiting, feeling of nausea, and sometimes it causes damage to the brain as well.
Okay. So please, any other question or clarification? Any other question or clarification? Oh, nice. So it was a pleasure having discussions with you, and I really enjoyed the class, because even though the class was an impromptu thing, you contributed a lot, which I really, really appreciate. And one thing about this course is that always you are supposed to read ahead. Even when you don't understand the concept, you try and grasp the few ones that you can you understand, so that when you come for the class or the session, you would appreciate it well. Because sometimes if you haven't read and we are spelling out some of these new concepts and everything, it becomes more or less like an alien to you entirely. But if you've read one or two things, the moment we mention some of these things, you begin to recall them and also understand it better. So that's my little advice when it comes to this course. Please try and read ahead. All right. So Richard.
Thank you, sir.
Yes, please, my concern here is about our next scheduled meeting.
Okay.
This one has been very effective, and if we are to carry on this way, help most of this population.
Richard, sorry, your voice was very low. I could hardly hear or barely hear you.
Can you hear me now?
Yes.
I'm saying that my concern is about our next scheduled meetings.
Okay.
Because as Christopher said earlier on, most of the student population are out of Sakai for now. So
yes.
If things schedule are made known earlier, then we'll be able to circulate the information, so most of our colleagues can also participate in the day.
Yes, I'll do that. What happened today was that even I think 2-3 days ago, your course rep called me to find out whether I'll be the one handling this course. But the unfortunate thing is I didn't receive feedback earlier, because due to the online, I didn't know whether I'll be assigned to this course or not. So I received the information. I think 5 minutes before the 4 o'clock that you had with Auntie Aquile.
Wonderful.
Then I had to schedule it and meet you guys. So in subsequent sessions, definitely I'll give you early feedback on that.
Okay. So please, another thing.
Okay.
Are you handling both general psychology and biological, or you're taking us through only the biological psychology?
Only biological. When it comes to level 200s, I handle only biological psychology.
That's great.
Yeah.
Thank you.
You're welcome.
Thank you, sir.
You're welcome. You're welcome. So that will be the end of today's lecture.
We are grateful.
Okay, thank you very much.
Thank you,
Very
thank you,
grateful,
thank
sir.
you.
All right.
Thank you, too, sir.
Okay, bye-bye.
So
We
please don't
appreciate
forget
you,
to
sir.
post the recording.
Yes, I'll do that. I'll forward the recordings to you.
Yes.
Thank you.
Okay.
Bye.
Bye.